Hello viewers, welcome back to my channel. I am here to deal with the interesting chapter of class 9, that is Introduction to Euclid's Geometry. So before going to start my video, let me remind you to get subscribe my channel and press the bell icon for my more upcoming videos. Okay. So the word geometry is there, no? It comes from the Greek word. Okay. So here the geo means land or earth and metrian in the sense to measure. Okay, so now the point is how the geometry has been appeared. The geometry appears to have originated from the need of measuring the land. Okay, so here what happened in Greek, many mathematicians, they have given many contribution to the geometry. Okay, so first we have to study about the Thales. Okay, so he was the Greek mathematician who has given the first known proof in geometry. So, which was the first known proof or first statement? We will see. The first statement or first known proof given by Thales is nothing but a circle can be bisected by its diameter, isn't it? So, if you will consider this circle, you can see here it can be bisected. It can be divided into the two equal parts by using its diameter. Okay. So, after that what happened? Thales' most pupils was Pythagoras. Okay, so Pythagoras and his group, they discovered many geometric properties. Okay, so after that what happened, you know, the Euclid, he was father of geometry and he was the teacher of mathematics at Alexandria. So he collected all the known work. Okay, all the known work he has collected, and what he has done, he arranged it in the form of treatise. Treatise in the sense here written work. Okay, so all the things whatever he has collected, that things he has arranged in the written work. Okay, that written work he called as elements. Okay, so after that elements again divided into the 13 chapters. Okay, that 13 chapters, like in this 13 chapters, each chapter is called as a particular book. Okay, so these books influence the whole world's understanding of geometry for generations to come. Okay, so in this chapter, we shall discuss Euclid's approach to geometry and shall try to link it with the present day geometry. Okay, so we will see now Euclid's definitions, axioms and postulates. So in order to study definitions, axioms and postulate, before this axioms and postulate, let us discuss about some of the definitions given by Euclid's. Okay, so all of you know about the solid, right? So first he has given one definition about the solid. The solid, it has a shape, size, position, and the solid can be moved from one place to another place, isn't it? So whatever I am holding here, this pen, this is a solid, isn't it? This is having a shape, this is having a size, and this is having one particular position, isn't it? You can you can move this from one place to another place also, right? So this is a solid. So now next thing is what? Surface. So here one solid I am going to consider, cube. So here you can see these boundaries, this boundary, this boundary, this boundary, this boundary, and this boundary, these sides. So these are called as surface. Okay. So after that, next you have to study about the curves or straight lines. So you can see over here, look at this figure. What happens here? The boundaries of the surfaces. So you can see these boundaries, isn't it? These boundaries are there, no? See, these boundaries of all the surfaces are called as curves or straight lines, isn't it? So these boundaries are there, no? These boundaries are called as curves or straight lines. Okay, so now again some of the definitions he has given. Let us see that. First one is, a point is that which has no part, isn't it? So now here just consider this point. Yes, I'm putting the dot over here, I'm putting the dot over here, here also I'm putting the point. So it is not having any kind of the part, isn't it? It's not having any length, it's not having any breadth, isn't it? So here the first definition what he has given, a point is that which has no part. Okay. So the next one is, a line is breadthless length. So here what is the meaning of this statement actually? The line is breadthless length. So here you can see, if I'll draw over here one line, straight line. So this line is a breadthless length. How you can define this? Breadthless in the sense it is only having a length. It's not having any kind of the breadth. Okay. A line is a breadthless length in the sense it's not having any breadth. Only it is having length. Okay. So the next thing is what? The ends of a line are points. Isn't it? So if you'll consider the straight line, what is happening over here? See here you can see the 2 points, isn't it? So these 2 dots are there, no? The ends of a line are always points. Okay. So the next thing is what? A straight line is a line which lies evenly with the points on itself. So now you can see, if suppose you will consider the straight line. So here this is a straight line, right? So this is made up of so many points, isn't it? If you will join so many points like this, like this, like this, like this, so what you are going to get? You are going to get again straight line, isn't it? So the same definition what they have given over here. A straight line is a line, okay, on which lies evenly with the points on itself, isn't it? So which lies evenly with the points on itself. When you will make like see here, when you'll do like this point, I'll keep the point over here like this, like this. So you can see this is nothing but a straight line. Okay. So the next thing is what? A surface is that which has length and breadth only. So I told you in like previous definition while explaining the solid, right? So it is having, if you will consider one surface, this is having only length as well as breadth. Okay. So next thing is what? The edges of a surface are lines, isn't it? So in that cube, yes, you have considered one cube, right? So in that cube, the edges of a surface, we have considered this surface, isn't it? If you will consider this surface, the edges, all the edges are always lines. Okay. So all the edges are there, no? These edges are always lines. Okay. So the next thing is what? A plane surface. Plane surface is a surface which lies evenly with the straight line on itself. Okay. So a plane surface in the sense a flat surface. Okay. So this kind of the surface is there, no, which lies evenly with the straight lines. You can see here this flat surface is there, no. If you'll consider this flat surface, that means plane surface, it is like evenly lies with a straight lines, isn't it? Straight lines. It is connected with the straight lines, isn't it? So now while explaining these definitions, he also explained about the undefined terms. Okay. So what are the undefined terms over here? Okay. So we will see first. For example, consider his definition of a point. So what he has given, actually the definition for point he has given as a point is that which has no part, isn't it? So now while explaining this, in this definition, first a part needs to be defined, isn't it? So if suppose you will consider the part, see here, point is nothing but it is that which has no part, isn't it? So while explaining this, you need to be explain again part, isn't it? So after that, in order to define the part, again you have to explain the area. If you'll consider, if you want to define the part means again something you will get as area, isn't it? So after that, if you want to define area means again you need to define length, breadth, etc., isn't it? So again and again you are going to get, you can't define it like easily. Okay. So to define one thing, you need to define many other things. Okay. So you may get a long chain of definitions without an end. Okay. So these kind of the terms are called as undefined terms. I hope you understood this. So what actually in order to define this point, you are getting again the point definition is what? A point is that which has no part, isn't it? So again you need to define here part. Yes. So after that, suppose if you define a part to be that which occupies area, again you need to define area, isn't it? So after defining area, again you have to define length and breadth again. Yes. So in order to define one thing, you need to define many other things. So and you may get a long chain of definitions without an end. So these kinds of the terms are called as undefined terms. So there are several kinds of the terms in geometry, undefined terms in geometry. So for example, point, line, plane, etc. Okay. So the next thing is what we have to deal with, the axioms and postulates. So in order to study the axioms and postulates, let us discuss first the definitions of axioms and postulate and the difference between axiom and postulate. Okay. So first thing is what actually the axioms are the assumptions which are obvious universal truths. They are not proved but can be used in many areas. Here you can see postulates are the assumptions which are obvious universal truths. They are not proved but specific to geometry. So here after studying the definition only I hope you understood, but I'll explain this what happened actually. If you'll consider the axiom, these axioms are some of the assumptions made by Euclid. This postulate also some of the assumptions made by Euclid. Okay, but here the main difference is what, these axioms can be used in all the areas, many kind of the areas, but these postulates are there, no? This is only specific to geometry. You can't use this in another field. Okay. So I hope you understood the main definition, like main difference between axioms and postulate. Okay. So now we will see the theorem. Okay. What is the meaning of theorem? Theorems are nothing but, again, these are the statement which can be proved using the definitions, axioms and previously proved statements. Okay, so what is happening actually? Axioms and postulates are some of the assumptions which cannot be proved, isn't it? But the theorems are there, no? These are like the statements which can be proved by using the definitions, axioms, previously proved statements. Okay, so now we will study the Euclid's axiom. Okay, so there are totally 7 Euclid's axioms. First one we will see, that is, things which are equal to the same thing are equal to one another, isn't it? So in order to understand this axiom, first what you have to do is just consider this straight line AB, BC, A, B, C, D and EF of length 3 centimeter, 3 centimeter and 3 centimeter. Okay, so actually what they have given, things which are equal to the same thing are equal to one another. So first I'll write AB will be is equals to CD, isn't it? Yes. So now CD will be is equals to EF. If AB is equals to CD, CD is equals to EF, then according to your Euclid's first axiom, what you can write? This first thing should be equals to the third thing, isn't it? That means AB should be always also equals to EF. So AB will be is equals to EF. Understood? So again you can directly consider like AB is equals to 4 centimeter, CD is equals to 4 centimeter and EF is equals to 4 centimeter. AB is equals to CD, CD is equals to EF. That means AB should be also equals to EF. Okay. So this is your Euclid's first axiom. Okay. So the next thing is what? If equals are added to equals, then the wholes are equal. So what is happening, if suppose two persons are there, person A and person B. The person A age is 15 and person B age is also 15. So after 3 years, what will be the age of the two persons? Same, right? 15 plus 3, 15 plus 3. So that will be 18, 18. So you can see if equals are added to the equals, then the wholes are equal, isn't it? So here also in the third axiom also you can see if equals are subtracted from the equals, then the remainders are equal, isn't it? So here also the same thing you can consider. What you can consider? If the person A is of 16 years old and B 16 years old, so before 3 years, what will be the age of person A, and before 3 years, what will be the age of person B? So 16 minus 3, 13 years. 16 minus 3, 13 years, isn't it? If equals are subtracted from the equals, then whatever the remainders will be there, that should be equal, isn't it? Yes. So next thing is what again? Fourth axiom. Things which coincide with one another are equal to one another. Okay. So before going to study this axiom, let me tell you what is the meaning of coincide. Coincide in the sense like which occupies the same place. Okay. So if suppose you can see here, this is your triangle ABC. This is your triangle DEF. So here these two triangles are equal. Okay. So equal triangles I have taken. So you can see when you will take this triangle DEF and just imagine that you are going to place this triangle on the triangle ABC, then what is happening actually? These two things will coincide. These two triangles will coincide. That means which these two triangles will occupy the same place, isn't it? So that means what you can conclude from this? You can conclude that, see here, these two things like angle A and angle D will be equal, angle B, angle E will be equal, angle C and angle F will be equal, like that, right? So things which coincide with one another are equal to one another, isn't it? So next thing is what? The whole is greater than the part. So if you will consider this as a whole chocolate, so you are having the big chocolate, dairy milk, okay? So in this dairy milk you can see small parts will be there, right? So if you are removing one bar over here, one small piece from the full dairy milk chocolate, so you can see here the whole, this whole is there, no? It is greater than this part. Again, if you will consider the daily life examples, means you can see India is greater than Delhi, isn't it? India is greater than Karnataka. So these are some daily life examples what you can use in what you can use here as Euclid's fifth axiom. Next thing is what again? Things which are double of the same things are equal to one another, isn't it? So if you will consider here 2x, 2y, things which are double of the same thing. Okay, so what is happening here? 2 will get cancelled. What is remaining? X is equals to y. Things which are double of the same thing are equal to one another, isn't it? So this you can conclude by using Euclid's sixth axiom. The last one is nothing but here. Things which are half of the same thing are equal to one another. So you can see over here, I have taken in the previous axiom, I have taken 2x is equals to 2y, right? So now you can see here x by 2, I am going to take x by 2 is equals to y by 2. If these two things, like half of these two things are equal, then whatever the answer you are getting, that should be equal. So here you can see 1 by 2 will get cancelled. What is remaining? X is equals to y, isn't it? So this is nothing but here Euclid's seventh axiom. Okay. If you are interested to watch Euclid's postulates, then wait for my next video. Thank you for watching my video.